Welcome to the Rich Report, a podcast with news and information on the world of cloud computing. Today, my guest is from SOASTA. We have Dan Bartow. He's the VP of Product Management. So, Dan, welcome to the show today.
Thank you very much, Rich. I really appreciate the opportunity to be here.
Well, great. You know, I brought your slides up. Why don't we start with that, and we'll follow it with Q&A.
All right, sounds good. Well, let's start on the About SOASTA slide. What I'd like to do is just tell you a little bit about SOASTA, if you're not familiar with us as a company, and then I'll talk about our product, which is CloudTest, and how we use the cloud to give companies the highest confidence they've ever had in their production application readiness. So let's just start with a little bit about SOASTA. We were founded in 2006, and we're a privately held company. We're based in the heart of Silicon Valley. We're here in Mountain View, California. And the company was, founded in 2006, but we worked for a couple years on our product CloudTest before we released it in 2008. And to date, we've got over 350 customers. We're very blessed and grateful. You can see some of the names on the right, names ranging from Intuit to Netflix and Microsoft, Gilt Group and Marvel, Capcom, some great names. And so we'll talk a little bit about some specific case studies actually at the end and how some customers are using CloudTest and the cloud. We've got 10 patents pending, and some have been granted in the areas of visual test creation, automation, and cloud grid provisioning, which is really our focus here in this talk. And we've gotten some nice awards and accolades. Wall Street Journal has named us one of the top 50 hottest companies in America for 2 years in a row, and we're named a Gartner Visionary Leader in the testing tools space. So let's go ahead and move on to the next slide. Performance matters. Web application performance is really important, and it matters to the point where some really big names in online applications and online retail have started to do some interesting studies. One of my favorites here on the left-hand side, you can see Amazon did a study where they showed that 100 milliseconds of latency in their page load time could cost them up to 1% of their sales. So 100 milliseconds really isn't that long. I think it takes something like 80 milliseconds for a speech to become thought. So if you think about the time it takes for you to think a word and then have it go from your brain to your mouth, measuring 100 milliseconds of page latency, Amazon has seen could cost them up to 1% of their sales. Another really interesting one, Google had an interesting routing problem with their DNS, some of you might remember a year ago, and they found that half a second latency cost them up to 20% of their traffic. So basically you go to Google, you make a search. We're used to getting instantaneous response, but even a half a second increase, 20% of their visitors will actually go try to use an alternative search engine like Bing or Yahoo, just because we're so used to that instantaneous response. So I probably don't need to tell any engineer who's listening that performance is important, but it's becoming more important than ever, and especially as we make our way into mobile and we look at applications that have varying performance profiles based on network, 3G, 4G, LTE. Performance is really important, and so our focus here is how can we use the cloud to do some large-scale testing and to actually generate results that will show that your customer experience is going to be great even as load increases. So here's how we've been performance testing in the past. Since the late 90s, the performance testing has been part of the software development lifecycle for web-based applications. But the way that we've done it is we would have a lab environment, we would test in a lab, and then we would do extrapolation to figure out how much infrastructure we needed in the production environment to support the peak that we were anticipating. And that was okay. That got us through a few years of the early days of the web. So back then, web traffic was small enough that you might actually have a production environment that was the same size as your lab. Let's say 2 web servers, 2 application servers, and 2 database servers. And so, and TurboTax Online, actually, which is where I come from Intuit, actually. I used to manage the engineering team for TurboTax Online from 2007 until late 2009. So TurboTax Online is a great example, one of the first SaaS applications. Been around since the late 90s, and when it rolled out, it had a handful of web servers, a handful of app servers, and a couple database servers, and the lab environment was a 1-to-1 match. Well, it's a good problem to have, but as traffic increases year over year, that production environment goes from 20 servers to 40 to 100 to hundreds, and in the case of some very successful applications, multi-data center and thousands of servers. Well, this is, if you're working with a web-based application, you may even be using this paradigm today. If you're fortunate enough to have a testing environment at all, you're testing in a lab and then just blowing those results out and extrapolating to figure out how much you need to support your real production traffic. Well, when I joined Intuit, it was a very interesting story, and this is how I became an evangelist for this type of testing from the cloud against production environments. I joined on April 3rd, 2007, and on April 15th, 2007, which you can imagine, tax day is the biggest day of the year for TurboTax Online, there was a huge outage, and it was really well publicized. In fact, Intuit's CEO had to go on CNN and explain to millions and millions of taxpayers why, for the first time in IRS history, they had extended the tax filing deadline because of systems outages shared between TurboTax Online and the IRS. But it really was a wake-up call for us. We realized that we needed to change our processes of testing and validation because this method of extrapolation just wasn't cutting it. So if we go on to the next slide. So testing in production really is the wave of the future, and this is the reason why a lot of big names in online retail have adopted this approach of testing in production along with countless other massive applications. It's because the things that you find when you test at full scale in production, they're just drastically different than the things we have ever found in a lab. So if we look at this slide, along the x-axis in the lower left-hand corner, starting in the lab, these are the types of things that we've always found while performance testing in a lab, right? We found garbage collection, we find inefficient database queries, code level issues, and we shake out the low-hanging fruit. But if we move on to something like a staging environment, if you're fortunate enough to have a staging environment, this is typically defined as a slice of your production environment that's running your production code. It's just not live to customers, but it's on the real hardware, it's in the real environment. If you can test there, then you can find different issues that you wouldn't find in a lab, things like running out of sockets on a machine if you're doing some scale testing there, inadequate server resources, search technology limitations in the production environment, security bottlenecks. But really, the goal is to run full-scale production testing. And so, once you start to crank up, let's say you've got an application that's, got hundreds of servers, you're expecting hundreds of thousands of concurrent users. If you can test to that scale, the types of things that you're going to find, you could just, the only way you would find them before you had the ability to test would be to just cross your fingers on the biggest day of the year and hope that you don't hit some of these things. Running out of bandwidth in your data center. And it sounds funny, but it happens. I've seen entire data centers run out of bandwidth because they just didn't anticipate that the amount of traffic they were going to get times the size of their content would eat up all the bandwidth they have. Firewall, max connections, DNS routing, right? We talked about the Google example where their DNS routing caused huge performance problems. So full-scale testing in production is definitely the wave of the future. In fact, 6 of the top 10 online retailers in the United States have, in advance of Cyber Monday last year, tested their application to 2 or 3x. These are names like Walmart and Sears and Target, right? They're testing their multi-data center architectures with hundreds of thousands of users using thousands of servers from the cloud as load generators to do this from outside the firewall. So we'll move on to the next slide here. The goal of performance testing, ultimately you want to deliver a great customer experience, but this type of testing comes along with some other nice added benefits. Companies are able to really experience their peak before it happens. And so this means you've got the right teams involved during the testing, the same ops teams that will be involved during the real test, and you can achieve this level of operational excellence to where if something does go wrong during a test and you want it to happen during the test, not your real peak, you'll be able to kind of work those issues out, see how the app is resilient and responds, and see how the people respond to these issues, and ultimately have a high level of confidence in the application. And moving on to the next slide, there's also a level of discipline and rigor and methodology built around this approach. I don't want folks who are listening to think that using cloud servers to generate load against an application is just firing up a bunch of load generators and spraying load and seeing if it breaks. It's not really about that. It's much more disciplined, and I don't want to spend a lot of time here other than to say that there's a methodology around this type of testing with some discipline about how you do it, because testing a production application to full scale from the cloud, there's some things that you need to consider. The 3 most common of those are, security. What about security of the application? What about test data that you might generate or access in the production environment? And then what about potential live customer impact? These are all things that come along with doing these types of tests from the cloud. So I just wanted to put this out there and say that there is a methodology around this. It's a lightweight methodology, but there's definitely some things that need to be considered before you just go testing an application in production. Although testing from the cloud is not limited to production environments, it's just for those kind of full-scale validation tests, it's got to be done against production. But you can still use load generators in the cloud to test an environment in the lab as long as you can reach it, or even a staging environment. So just as we get into our product here and just the general approach of using the cloud for testing, it doesn't really matter where the system under test is. You're testing from outside the firewall to achieve these types of results. And I'll just show the next slide. It's about speed, building, testing, and analyzing those results. Testing from the cloud just gives you an unprecedented level of data, again, in those areas that we've never been able to touch except through experiencing it on our production peak with our fingers crossed. So let's jump into the CloudTest platform. CloudTest, the product, is a testing product. It's a web-based application, fully visual, and it enables 4 distinct types of testing, both functional and performance testing. If you're not a tester, just a real quick definition of those. Functional testing is typically described as 1 or 2 users worth of load, just validating functionality. Is the login box there? If I click login, does it work? It's a pass-fail type of test. Performance testing is more about the speed, transactional speed, page speed, and then scalability and capacity type testing. But our product enables this for both mobile and desktop applications. So protocol level testing as well as mobile application testing, whether you're simulating them or using real devices. So that means we can generate HTTP traffic or we can drive real browsers on real machines. It means we can simulate mobile traffic or we can drive real iPads and real iPhones and real Droid devices. So it's a product that has 4 distinct types of testing in it, but it's all done inside the same product. Same code line, same test creation interface. And when we talk about cloud here, most of the listeners will think of the cloud as a place to deploy applications to and a place to get servers for traditional types of applications. But one of the things we're working on here at SOASTA is the notion of public and private device clouds. So in the same way that cloud computing solved access to infrastructure and cost issues associated with infrastructure by virtualizing and allowing access and affordability with cloud computing, we think that, and we're really trying to pioneer this space of the private cloud. We think the same thing is going to apply to devices, private and public. So what we're seeing is a lot of enterprises, they want to test their application on Droid devices, but there are hundreds and hundreds of flavors of Droid. But they don't want to buy all 300 of these devices, but they still want to validate that their app works on them. So this notion of a public device cloud or a private device cloud, either inside or outside the firewall, is something you're gonna see coming, we believe. And we're definitely trying to spearhead that effort. The CloudTest platform, the second slide, again, we described the differences between mobile and desktop testing. This is just a little bit more of a level of detail, but from a performance perspective, typically we're talking about generating HTTP traffic, web services traffic that would come out of apps. From the functional perspective, we're talking about real browsers, real devices. So let's move on to the cloud test slide. I mentioned that we're fully web-based and fully visual. All your test creation, your execution, your analytics are all done through a web browser. You can see that this was Safari when I took this screenshot. I'll move on to the next slide. Visual test creation. Where cloud test really differs from other test creation solutions is that instead of having to write code, we're fully visual. So this is a patented interface. We were awarded a patent on visual representations of actions that users take through applications, whether it's mobile gestures or whether it's HTTP requests. And the same visual interface is what we use to spin up servers in the various public and private clouds to act as load generators. If we move on to the next slide, it says Cloud Test on Demand, cloud-based service. This is the architecture. This is how the product works. Essentially, you log into Cloud Test from anywhere. That's the engineer on their laptop on the far left-hand side. And we've got our, our main and our analytics and database that make up the Cloud Test product. But what our product lets engineers do is dynamically provision servers in pretty much all of the well-known clouds. So you can see AWS, IBM, GoGrid, Rackspace, Azure. These are just some examples of APIs that we've integrated with. But what you'll do is you'll go into Cloud Test and you'll say, I want 10 servers in EC2 East, which is Virginia. I want 20 servers in Rackspace Chicago. I want 50 servers in IBM Toronto. And what our product will do is actually go out and dynamically provision servers. So we'll say, give us these servers of this size in these different data centers. And we'll make API calls out to all the different providers that you've defined in your grid. We'll provision those servers. We'll health check them. That's a really important part of cloud. I'm sure all the cloudies that are listening are familiar with the fact that, because it's virtualized infrastructure, shared infrastructure, just the nature of the cloud is sometimes you get a lemon when you're spinning up some servers, and sometimes the server will just go bad, either because of noisy neighbors or just because of the nature of the fact that we're using VMs on, servers in data centers. Hardware does fail. VMs do fail sometimes. So what we'll actually do is health check all these, both when the cloud is and the grid is initialized as well as ongoing to make sure they don't go bad. Then what you end up with is a nice grid of servers that you can use as load generators to simulate hundreds of thousands, potentially millions of concurrent users like some of our customers do. And then you test your application environment. And I already mentioned that this could be inside the firewall, it could be in the cloud, it could be a production environment, it could be a lab environment, doesn't really matter. What you've got is a load generation cloud that's suitable for use in testing your application. On the next slide, the cloud locations. These are just some of the cloud locations that we have. I've kept I kept it specific to location, not so much provider, but if you're using Azure or EC2, you'll know which of these are from which locations. But we've got this nice global test cloud that we can spin up servers. I think at last check we've got something like 50 locations and 500,000 cloud servers that we can access at any given time. We're actually one of the biggest consumers of cloud resources at SOASTA. At any given time, we've got thousands of servers across the various clouds in use for purposes of testing, and our customers are spinning up, hundreds of servers, thousands of servers to do their own testing. So we're a huge consumer of cloud computing. And if you think about it, this use case of testing from the cloud or using the cloud as load generators is actually one of the best uses of cloud that one could think of. When we think of cloud, we think of a place to deploy applications to, but spinning up lots of servers and only using them for a few hours, there's only a few areas where that's really useful. Rendering video and audio is one of the oldest uses in render farms of large amounts of compute power. So cloud has really helped change the game there. Financial data and crunching, stock data, DNA sequencing, things like that. But performance testing. This actually, I would say, is the killer app for cloud computing. Spin up some servers, use them for a few hours, spin them back down. It's a great use, and so that's what we've been doing since 2008. This is our global test cloud has grown to include these locations. And then these are just public cloud locations. You can actually, through private clouds, even if they don't have an API exposed, you can really add a load generator anywhere. So we find that most people just use the public cloud. The global test cloud slide, this is actually a screenshot from CloudTest. This is where you would go to provision a test cloud. And you can see in the dropdown, here are some of the locations in the CloudTest product. It's a really, really cool process. CloudTest will allow you to spin up thousands of servers in potentially under 10 minutes, depending on the cloud provider. Not all cloud APIs are created equally. Amazon EC2 by far has the fastest API. So you can, I personally actually requested about 1,500 servers and got them in under 10 minutes because EC2 just have a super fast API. Azure is still pretty fast, but servers take on average 11 to 15 minutes to spin up, and then some of the other cloud providers might take as long as 30 minutes. But Amazon keeps their cloud servers kind of on hot standby, so when you ask for them, they're not spinning you up VMs really on the fly. They just mount your machine image and go, so they come up pretty quick. So this is that interface that I mentioned earlier. You can go in and define the different locations and how many servers that you want in each location. And when you go to the next screen and click deploy, all of it happens automatically. You can still use the cloud for testing even if you didn't use CloudTest. You just have to go through all the different APIs of the different cloud providers, get your machines, manually plug them into a test tool, and CloudTest has really made that whole process easy by provisioning them, health checking them, and loading them into the product. So we're coming down kind of the home stretch here. I wanted to share some real-world examples about how customers are using this to test right now. I mentioned 6 out of the top 10 online retailers in the U.S. use the cloud to test their application ahead of Cyber Monday. Well, some cool things that have been going on and are taking place right now. The iPad 3 launch, which happened just recently. We did a lot of testing with Verizon Wireless in advance of their launch. On the next slide, this is a little bit of a map of how their testing worked. Their performance testing team is actually located on the West Coast, but we used servers from Chicago, Dallas, and London to test their application infrastructure, which is located in New York. Now, if some of you remember the AT&T wireless fiasco when the iPhone launched years ago, Certainly AT&T subsequently, as well as Verizon, didn't want to have a repeat of this because demand for Apple's devices has just been so huge. So, Verizon, in thinking forward, decided, hey, we want to do some testing. We want to test not only the traffic level that we're expecting. Really cool event that's taking place right now is demand is just so fanatical for these devices that we could be wrong. Maybe our marketing and analytics are off. So we need to make sure we have enough buffer. So what they did was they spun up servers in the Microsoft Azure cloud, the Rackspace cloud. These are the three you see here are Rackspace locations. And they generated lots and lots of traffic against their architecture located in New York to validate that they'd be able to sustain this level of traffic. And ultimately, they had a great launch. On the next slide, another really cool event that's taking place right now is we're testing in anticipation of the 2012 London Olympics. So as you can imagine, when tickets go on sale, it's going to be, because it's limited space, huge event. There's going to be tons of demand for getting tickets. So they don't want their application to crash. They don't want to have bad brand visibility impact. They don't want to lose revenue. So we're doing a lot of testing. You can see significantly more locations here because it's a worldwide event. But we're using cloud servers in EC2 East and EC2 West United States, down in Sao Paulo, Australia, South America, China, basically generating load against the architecture, which is hosted in London, to make sure that when tickets go on sale, it's a seamless, flawless customer experience. I just read an article about a week ago. The data center that hosts the architecture for the London Olympics has built-in bunk beds and living quarters for the 24/7 staff that's going to be there throughout the Olympics, ahead of the Olympics and throughout the Olympics. That data center takes care of everything from the e-commerce aspect to the event and scheduling and traffic, all the way through the video streaming. And so they're taking the performance of this very seriously. And one of the things they're doing to make sure that they don't have issues is this kind of full-scale testing, using the cloud from outside the firewall to see what their customer experience will be, to see how their application responds. And so it's a really neat usage of cloud. When I first started talking at conferences in 2009 about this approach, invariably when I got to the end of the talk, people would still think that I was talking about moving their production application to the cloud so that they could test it there. Not what we're talking about. We're talking about infrastructure as a service, provisioning servers for use as load generators, and then using a test tool to generate that full-scale load. It's a neat approach, and we're seeing it adopted very heavily. I would say 10% of the class that I would present to in 2009 would say, hey, that's a pretty cool idea, and the other 90% would say, wow, we would never be able to do this type of testing in production. No way. Leadership would never go for it. And there's been a huge shift. I just finished the spring conference tour, and I would say it's completely flipped. 90% of the people in the room say this is a great idea, or I'm doing some form of external testing now, and 10% are warming up to the idea. I truly believe, I'm not one to make technology predictions, but just based on the data that I have, I truly believe that in the next 5 years, everyone will be doing some form of external testing against their application just to make sure that they have a good peak traffic day, that there are no surprises. It's just so intuitive, so logical, and cloud really makes it easy. So that's all I wanted to present. Rich, I'd love to flip it over for some Q&A.
Well, great. Thanks for that, Dan. So a question about the cost. What does it cost to test something of hyperscale like the Olympics versus what would it cost them to fail to test and not be up and running when they need to?
Yeah, that's a really good question. And when people come to me and ask, how can I build a case for doing external testing? The ROI versus the revenue loss or the brand impact loss is the best place to start. At TurboTax, it was interesting. Without a critical site outage, I'm not sure I would have had much success in championing this idea of external testing from the cloud, except for the fact that there was enough of a wake-up call through an outage that really people realized they needed a different way to go. So, the cost of an outage, referring back to some of those numbers that Amazon showed, 1% of their sales for an application as big as, and that's not even an outage, by the way, that's just slowness, right? 100 millisecond slowness, 1% of their sales. An outage, going back and looking at the retail season this last year, there's some interesting data put out there by a company called Catchpoint, where they basically were tracking all the big retailers to see if there were any outages on Cyber Monday. And the biggest one that I could find was there was an 80-minute outage on Victoria's Secret, and then things like 15, 20-minute outages on Toys R Us and things like that. that's a lot of revenue. If you're talking about your peak hour, and most applications will have a peak day and a peak hour, especially revenue-based applications, that is a ton of money. A 15-minute outage or a 1-minute outage. There was an outage on PayPal not long ago, and they lost millions of dollars in a 1-hour outage. I mean, that's just wild. So it's all about that peak for online applications. I mean, if you have a very cyclical traffic pattern, daily, weekly, monthly, you know that you can sustain that peak. But then when you get to the biggest day of the year, that's an unknown. So the cost of not testing and having an outage is way, way, way higher than testing ahead of time, potentially impacting some live customers while doing that testing, but you're doing it in controlled circumstances, and then knowing that you're going to have, at least with as high confidence as possible, you're not going to have an outage is really key. Cloud computing costs, I mean, these are well-known numbers. Let's say you need 1,000 servers to generate load. And by the way, that's a huge test. Most people don't need 1,000. Well, at 34 cents an hour, you're talking about $350, right, an hour. And these are some of the biggest tests out there. More than likely, you need 10 or 20 at 34 cents an hour, that being the price of an EC2 large. And then you need some kind of product, and you need some people to facilitate the testing. But it's just so logical. People have invested money in test labs. They've bought 20 physical servers to host the application on in a lab, as well as to test, act as load generators. And so at $5,000 a pop for each of those servers, you're already investing money in a test lab. This is going to get you greater coverage, and it's probably going to cost less depending on the frequency. So I think when people start to drill into the numbers, it's just, again, it's so intuitive. I really think everyone's going to be doing this. And certainly, 6 out of the top 10 online retailers doing it. I think and that's, by the way, I don't know about the other 4. I just know for sure that 6 did it. I think the other 4 will be on board, as well as countless other Fortune 100, Fortune 500 customers. So yeah, the cost of an outage, if you can get leadership to think about being proactive, I mean, it's just so obvious and so intuitive.
So Dan, I'm curious, when I worked back at Sun, our customers would over provision as a way to avoid outages, right? They figure out what they thought was their peak, and they'd buy 50% more than that and have it running all the time. Do you see that kind of behavior changing now that they have a way to really test what it's going to take to pull off the big gig as it is?
Absolutely. Throwing hardware at the problem is like the oldest solution to web-based scalability problems, right? And that is definitely changing, because especially for the larger apps, but for smaller and mid-sized companies, those $5,000, $10,000 a pop, I mean, that starts to really add up. For big companies, it's definitely not cost effective. If you think of something like a Walmart, a Target, or a Sears, we're talking about 2 to 3 data centers with thousands of servers per data center. These are massive clusters. To increase, in 20% traffic year over year, to throw 20 to 50% of the hardware at that is just completely insane. And so they don't want to do this. That's why they're definitely testing from the cloud. You can get really realistic data. Now, you cannot answer 100% of the questions about performance, scalability, and capacity, but this increases your coverage drastically. You're not going to catch all the use cases. Bugs do still slip into production, but if you think about it in terms of coverage, if testing in a lab got you 15% coverage, testing in production will get you, I would say, 75% coverage in terms of answering questions about the scalability, the performance of the code, and the architecture. And that's another great ROI mechanism, by the way, to use to build this case for using the cloud for testing. The cost of over-provisioning and along with revenue loss, that all makes up a really compelling case.
Well, great, Dan. Well, kind of a wrap-up question here. If our listeners have see value in this, I mean, is there a way for them to kick the tires on the SOASTA solution?
Yeah, absolutely. We actually have a free version of our product called CloudTest Lite, and you can get it from SOASTA.com. It's not a trial or a time bomb version. It's a legit free version. It'll let you do up to 100 virtual users of performance testing, as well as browser-based functional testing. And soon, when we go GA with our mobile testing solution, you can automate an iOS and an Android device in our free version. So it's really meant for developers, single developers and single engineers to do testing on their application. And again, no strings attached. We need your email address for a license key to send you a license key. But other than that, it's a full-on free version, and it's seeing really good adoption out in the marketplace. So I would say CloudTest Lite is the best place. And then if you want to run some larger tests, then that's definitely something we can explore with you. But 100 virtual users is actually quite a bit of load, and you can run that from anywhere you can run a virtual machine. So,
Terrific. Well, Dan Bartow, I want to thank you once again for coming on the show today.
it was a great opportunity, Rich. I really appreciate it, and thank you so much.
Okay, you're welcome. Okay, folks, that's it for the Rich Report. Stay tuned for more news and information on the world of cloud computing.